Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 100 minus 2 to the power of 99. So for my solution, first start with 2 to the power of 100 minus 2 to the power of 99. Now, I'm going to first rewrite 100 here as 99 plus 1, because 100 is equal to 99 plus 1. So I have 2 to the power of 99 plus 1 minus 2 to the power of 99. Now, an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 99 plus 1, and I can think of a here as 2, m here as 99, and n here as 1. So this will get me to a to the power of m, so 2 to the power of 99 times a to the power of n, so times 2 to the power of 1. And I have this minus 2 to the power of 99. Alright, so now, from here, what I'm going to do is I'm simply going to factor out 2 to the power of 99. So now I have 2 to the power of 99 times, 2 to the power of 99 times 2 to the power of 1 divided by 2 to the power of 99 is simply 2, minus 2 to the power of 99 divided by 2 to the power of 99 is 1. So now I have 2 to the power of 99 times 2 minus 1. Well, 2 minus 1, that's simply equal to 1, so I have 2 to the power of 99 times 1, and this is equal to 2 to the power of 99. So this is my answer. Now, I actually have a second method to solving this problem. So the second method, first start off with 2 to the power of 100 minus 2 to the power of 99. Now, instead of rewriting 100 as 99 plus 1, I'm going to rewrite 99 as 100 minus 1. So now I have 2 to the power of 100 minus 2 to the power of 100 minus 1. Now, 100 minus 1, this is the same thing as 100 plus negative 1. And remember, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, 100 plus negative 1, that's going to equal 2 to the power of 100 times 2 to the power of negative 1. Now, I can go ahead and factor out 2 to the power of 100. So now I have 2 to the power of 100 times 2 to the power of 100 divided by 2 to the power of 100 is 1, minus 2 to the power of 100 times 2 to the power of negative 1 divided by 2 to the power of 100, simply just 2 to the power of negative 1. Now, this is equal to 2 to the power of 100 times 1 minus 2 to the power of negative 1 is 1/2. And 1 minus 1/2, that's simply equal to 1/2. So I have 2 to the power of 100 times 1/2. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. So 1 over 2, that's the same thing as 2 to the power of negative 1. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 100 times 2 to the power of negative 1, it's going to equal 2 to the power of 100 plus negative 1, which is equal to 2 to the power of 99. So that's another method, but more complicated method of solving this problem. Alright, so I have 7 to the power of x is equal to 70. So I want to find the value of x here. So for my solution, first start with 7 to the power of x is equal to 70. Now I'm going to take the log on both sides. So now I have log 7 to the power of x is equal to log 70. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this would equal b times log a. So in the case of log 7 to the power of x, I can move x to the front. So that's going to equal x times log 7, which is equal to log 70. Now log 70, that's the same thing as log 7 times 10. And now if I have something in the form log a times b, this is simply equal to log a plus log b. So log 7 times 10, that's going to equal log 7 plus log 10. Now I'm going to go ahead and divide both sides by log 7. So then these two are going to cancel out, and now I'm going to be left with x is equal to log 7 plus log 10 over log 7. Now this is the same thing as log 7 over log 7 plus log 10 over log 7. So now log 7 and log 7, these two cancel out, so now I'm left with x is equal to 1 plus log 10 over log 7. Now log 10, that's simply equal to 1. So now I have x is equal to 1 plus 1 over log 7. Now what we're going to do is we're going to find the value of log 7. So log 7, this is equal to 0.845. So now I have x is equal to 1 plus 1 over 0.845. So now 1 over log 7, or 0.845, the value of that's going to be approximately 1.18329. So now if I add that with 1, I get 2.8329. So this is my answer. Alright, so I have x to the power of x to the power of 5 is equal to 100. Now the first thing I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, m and n are interchangeable, meaning this could also equal a to the power of n times n. And if a to the power of m times n is equal to a to the power of m to the power of n, then this means that a to the power of n times m, this is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we could think of x to the power of 5 as m and 5 as n. So if I switch those two places, I get x to the power of 5 to the power of x to the power of 5 is equal to 100 to the power of 5. Now 100 I can rewrite as 10 to the power of 2. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 2 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5, that's going to equal 10 to the power of 2 times 5, which is the same thing as 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 5 is equal to 10. Now I'm going to take the fifth root on both sides. Then these two cancel out, and now I'm left with x is equal to fifth root of 10. So this is my answer.